It's time to learn a major new language feature in Python, and in fact a major new programming concept, which is called object-oriented programming. You may have heard that term before. The specific language feature we're going to be using is something called classes. Classes enable us to structure our code even more cleanly by having a deeper separation of concerns, so that when we have a bunch of code doing one thing, we can put it over here and it's completely packaged up and separate from this other bit of code over here that can be completely packaged up and separate. They can use their APIs to talk to each other when they're needed to, but each part does their own thing. Do you remember the example that we did in class a little while ago about banking? The basic requirements were that you would have customers. Each customer would have a set of accounts, and each account would have a set of transactions with dates, and you could add or withdraw money so that you could see the history of transactions and see the current bank balance, right? It actually seems like a pretty reasonable and surely very common kind of thing that you would record and use a computer for. And you want to make sure that code is nice and clean and well structured so that you have very high confidence that it works. So if we were to try and use the tools that we have now, how would we go about doing that? Well, let's think about our data structure. We might have a list of customer names, and maybe there's three customers, me and my daughters, Dana and Aviva. And maybe they have different balances for each account. Balances, actually I guess we want to start with the account, so maybe we have accounts. And wait a second, now we already are going to have a trickiness because each customer needs a list of accounts, so I guess we're going to have a list of lists. So the first person, Ben, can have a list which has a checking account and a savings account. And maybe Dana has a list which only has one thing, which is a savings account, and maybe Aviva, who is younger, doesn't have any bank account at all. Okay, that might work. It's a little bit tricky. In order to do this, we have to know exactly what is going on, and each account has to be, right now, is hard-coded with the list of customers. So if you update your customers, you have to update very clearly, very carefully, the count. Like if we were to go and insert a new person in here, which is my wife Allison, well, and then we went and put her accounts at the end. Maybe she has I don't know, some kind of market account. Well, we just introduced a bug, didn't we? Because we put Allison as being the second customer, but we put her account at the end. We've got a problem here because we are kind of mixing up our different parts of the data structure. Why should the account list have anything to do with the customers? Each customer should have their own set of accounts. Combining them together is giving a great opportunity for a bug. We're going to solve this by using classes. So let's take a step back and talk about classes. Classes are a way to represent essentially a template for a data structure and associated code. That is, suppose what you want to do is describe what kinds of things a customer can do, including what kind of data you want to store with a customer, maybe their name and maybe some personal information like their phone number and address. And then you might want to define some operations you can do, right? Which is create an account, print out their account transactions, print out their ledger, maybe do some other things, add money to an account, remove money from an account. Actually, I guess maybe that would be associated with an account. The key idea is that you want to define what the customer can do, and then you want to say, okay, I want to make one of those customers in my system for this person, and then I want to make another instance of that template for this person, and then I want to make another instance of that template for this person. And then same for accounts. Maybe we want to define a new thing called an account. An account has an account name and maybe a list of transactions. Okay, so we create this account, this template, and maybe it has some operations on it, then we want to be able to make an instance of that in an account. Maybe you want to make a checking account and assign it to me. And you want to make a savings account and you assign it to me. Then maybe my daughter wants to have her own savings account. So again, we define an account template and make different instances. Okay, we're just talking about this banking example, but it turns out just about every bit of code that you write, it is often useful to define a notion of a template, a reusable template, and then you make an instance of that. Suppose you're making a graphics program and you want to be able to draw some images. Well, let's make a class that represents image, which is our template, along with some operations like load image and display image, and maybe rotate image and other things you can do to it. Then we can make an instance of that class for each image that we load. So we load this image, we make a new instance, and we use that to manipulate and display that image. Suppose we want to make a simulation. We might have a template for the world and make an instance of it. Well, for now we only have one world, but what if you want to have another world? Well, right now with our code it would be a mess because we have everything hard-coded to one world. But if we had a world class, we could make one instance and then another instance. And even with our single world, suppose we wanted to have multiple creatures. Again, we could make a class for a creature and then define one instance for that creature and then another instance. So the key idea about classes is that you first define a template which includes data that is associated with each instance along with functions that operate on that data for that instance. And then you can make multiple instances, and for each instance you get your own copy of the data. So I've drawn here a representation of the templates, that is, the classes. We might have a customer class with data, which is a customer's name and its list of accounts. Now remember, that is data that is associated with each instance of the customer. And then there might be some functions, add account, and maybe print out the customer's information. Now I'll note that when you use a function for a class, it has a different name, and we call them methods. Similarly, we can have an account which has the name and transactions along with several methods, deposit, withdraw, and print. And maybe a transaction which has the date and amount just lets you print. And I'm assuming that that's because when you create the transaction, the act of creating it sets the date and amount. Now when we do this, this is our templates that is in our sort of the static part of our code. Then we have the runtime part of our code, which makes instances of these things. So maybe I make an instance of a customer, which represents me, Ben. And it's got some data in it, right? My name and list of accounts. And so the list of accounts might be a reference to a list, right? Where each cell in the list is an account, an account, an account, an account, and so on, where each account has a list of transactions. And so maybe, let's give it another color. Here's a list of transactions, which might have a date and an amount. A date and an amount. And so maybe this account is a reference to this list of transactions. And these other accounts will be references to other lists. And this is just Ben. Allison can be another instance of customer which references her own accounts, which references their own transactions. Now we can go and see what this looks like in code.